Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, well, welcome everyone. Today we have with us Renee Shah. And Renee and I had this amazing conversation a couple weeks ago about Wasm and distributed systems. And I was like, oh my gosh, we got to have this conversation again so that other people can enjoy it as well. So welcome, Renee. Great to have you.
Thank you. It's great to be here.
So, Renee, just real quick for some background. Renee, you work at Amplify Partners. Can you tell us a little bit about what you do there and what Amplify does?
Yeah, so I'm a partner at Amplify Partners. We're an early stage venture capital firm, and we only cover two core spaces, infrastructure and developer tools. So we tend to know these spaces really well. About half of our companies are open source. So that's a go-to-market motion we understand really well. And the best part of my job is that I get to just look at all the new projects on GitHub and Hacker News and think about distributed systems and developer tools all day.
Awesome. Love it. It's a place that Bruce and I are passionate about, is making developers more productive and helping them build more reliable, scalable systems.
Open source, the whole.
Yeah, and open source. So.
Whole, yeah. What that does. So, so you're at a venture capital firm. And a number of years ago, I decided, okay, I want to try and figure out this management thing. And I spent 7 or 8 years reading and visiting companies and writing about this until I finally realized that pretty much the whole thing was a scam. So I don't know if you've read this book.
I have not read it.
This book, anyway, this guy he had gotten his PhD in philosophy, and then he joined a management consulting firm, and he saw it from the inside. And then he wrote this.
The book is called The Management
Myth. And he wrote this using the logic that he learned in philosophy to kind of dissect everything. And anyway, so there are so many things that we do in accepted management that are such terrible ideas, and we know that they're bad. I mean, like Freakonomics just did an episode on the Peter Principle, which is the one where you rise to your level of incompetence. And management knows, and the Freakonomics guy thought, oh, this must be a joke. But then he looked at the actual evidence, and it's like, yeah, the impact is like 30% profits, and it's like, and management knows about the Peter Principle, and they keep doing it. So my question is,
they keep doing it because they've been Peter Principled, and they just don't, they're now in their level of incompetence, which includes being incompetent to change the Peter Principle.
It's a combinatorial thing. So I don't think that companies now, because when you get into, the C-suite, you don't look for a way to replace yourself, even if you're doing a terrible job. Because you're convinced that you're getting all this money, so you have magical powers of decision. And so what I think the future is going to be, and I think it's got to start with VC firms, is the VC firm is going to come up with an AI that does management. And because, what's a good hit rate? 1 out of 10. If you can say hit 2 out of 10 or higher, you're going to be awesome. So that's why the VCs are going to be driven to do it. The right firms are going to be driven to do it. And they're going to say, okay, you're going to be managed by this, which is going to make scientific decisions rather than decisions based on management myths.
So let's not replace the developers with AI. Let's replace the managers with AI.
Well, I think that's where the huge advantage is going to be. And then you're not paying, hundreds of millions of dollars to people because they have magic powers. You're going. You see what I'm going.
I do. I like the idea. I think the only tricky part is so much of investing is the market and just riding a big wave, that a great team is always good and always helps. But even with AI, if it's the wrong market, we may still lose money.
Oh, yeah. I'm not saying you're going to hit 10 out of 10, but I'm saying I believe you're going to do a lot better if you say, here's your management AI.
So I
Just
think,
do your-
Renee, what you were saying was that finding the market fit and making sure that your company is aligned with market fit, that maybe is something that an AI wouldn't be very good at. But maybe like as an organization grows, the actual like organizational management side of things, maybe that's a piece where AI could help. But on the market fit side, it does seem like having people that really understand the market, understand their customers, like that still is a unique human
Yeah, I'm
skill.
not
maybe.
talking about that.
Okay.
I'm talking about, for example, the Peter principle. It's like, okay, the AI is going to go, oh, no, this is costing us a lot of money. When you hit your Peter principle, we're going to back you down to your level of competence or something like that.
Right.
Or,
I
or
mean,
the,
yeah, I'm with you that the Peter principle is very real. In fact, I used to work for a management consulting firm called BCG, and they had an up or out principle, meaning if you didn't make the next promotion in the next 2 to 3 years, you actually got fired. And
Whoa,
that was a way to
brutal.
keep low performers from sitting in those roles for too long. And so it was
Huh.
actually a really, really talented organization as a result. It definitely, though, added
Filtered out the
some
Peter
stress.
petered people
well, I know, but then you're throwing away people that you have
that may be
trained
good
who
in
would
another
have
role or
been
something.
good in the role below their Peter principle if you're hierarchical.
Maybe AI, instead of replacing management, augments management such that the Peter principle doesn't have the power that it normally has. Or
Right.
maybe
Something.
you don't get Peter principle because you use AI to help cover your gaps.
We don't know. It's machine learning. It would actually be looking at evidence rather than fads to make, to come up with how it's doing its management. And so all of those things would be possible.
Yeah.
We don't know.
Seems
Okay.
like a possible experiment for Renee on to go to one of her next companies she invests in and says, "How do you feel about AI managing the company?"
Yeah.
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 Let us know if you can come back on if you can do this experiment. Let us know how it goes.
And my belief is that some smart VC firm is going to say, we need to develop the AI to do that management.
Yeah.
So anyway,
Good idea.
let's talk about what's that? Go ahead.
I said it's a good idea. I'll suggest it to my partners and to some of our portfolio and report back.
Nice.
Awesome.
Yeah.
Mission accomplished, Bruce.
Okay.
All
I
right.
just want to get the idea out there.
Yeah. Bruce has been on a mission for many years to fix organizational structures because they're broken.
In so many ways, but also to the point where I'm kind of broken from trying to figure it out. So
yeah,
I'm back to technology.
There you go.
I have been
Fix
for
it
a
with
while.
technology.
Yeah.
Okay. Fascinating. Any other closing thoughts on that subject, Renee?
No closing thoughts, but I like the creativity.
Thank you.
So, in your role, you're looking at what's happening in the developer tools and infrastructure spaces and looking for possible places to invest. Sounds like that's generally your role.
And it sounds like you're scouring GitHub to do this or something.
That's certainly a part of it. I think the projects that are trending on GitHub always provide really good investment signal, especially when you see a couple similar projects trending. But the way we create theses is actually through platform shifts. So you can take the biggest platform shifts like the shift to the cloud, the shift to microservices, the shift to serverless and edge. And with each shift, there have been billion-dollar winners. For example, VMware was a winner with the shift to the cloud. Docker was a billion-dollar winner with the shift to microservices. And now we're seeing this huge shift to edge computing. I certainly don't think it'll be as big as the shift to the cloud, but we have Fastly and Cloudflare providing compute at the edge in addition to a number of others. And it kind of goes hand in hand with running serverless workloads. And so we've thought a lot about what class of companies that can enable. That's just one way we come up with these theses.
So you have seen some of these shifts over the last few years. The edge one I want to talk about. Also, things we may head on is functional programming, distributed systems, Wasm, some of these other shifts. But let's start with edge. So, give us the rundown. What is the whole edge shift? What's that encompass?
Yeah, that's the $1,000,000 question. I think edge is one of these really poorly defined terms. So it certainly can be IoT, industrial IoT, edge devices like your cell phone or an autonomous vehicle. It also just could be a server that's closer to the user. So traditionally, clouds have had all their servers in data centers, and you were kind of locked into those. We saw companies like Fastly, even 10 years ago, sort of build CDNs, which were more for static sites, but the POPs, the point of presence, were closer to the user. Now we're seeing people actually running compute closer to the edge. So they're using
So
those
not just
server
static
buses, and
content,
it's
but
not just static content.
yeah.
Exactly. And that's the biggest shift we're seeing of late. Um, I think both could encompass the edge, IoT and edge servers. I'm a little bit more interested in just the idea of, okay, now we have all these servers really close to users, that can create much, much, much lower latency, which is one of the big benefits among others. And what class of companies want to use those, and how do we make these edge servers smarter, doing things like state management, which have historically been left for the clouds, and really build compute on the edge, and kind of change the way that developers can build edge native applications.
This sounds to me, I mean, I've been immersed in concurrency for the last, I don't know, few years. And this really, I mean, if you look at the basic definition of concurrency is uh, executing pieces of code independently. This sounds like
So
a
that
variation of concur. Well,
what's the so that?
well, yeah, the whole point is to make progress faster. And that's what you're trying to do. You're saying, oh, well, we have all of our, in the cloud, all of our processors are, in the data center. And what we want to do is move pieces of that task out to these other processors that we have available.
So that we can make progress faster.
So that we, yes,
yeah,
obviously,
similar to
yes,
the goal
it's
of concurrency. Yeah.
always,
Yeah.
that's the thing.
And
So
there's
in that space, it's moving the compute seems generally easy. I think maybe the platforms are not kind of universally there yet. I think you identified Fastly as being one of the ones who's kind of brought that to the forefront. But isn't the data the hard part? That then you're building a distributed system with distributed data, and now you've just entered into a massively complex world.
Totally. And you nailed the hardest problem, which is data is the hardest part for the edge. I think that's slowly changing. I mean, Cloudflare has put out two edge databases, uh, D1 and R2. They're quite good. They're getting better. And then we're seeing a number of companies think about data for the edge. A new one is called Terso. They are doing SQLite replication. So a lot
Huh.
of people think that SQLite is the best edge database, but replication has historically been a problem. This company is going to solve that. I feel like for most of distributed systems, it's always the state that creates the problem in the end for every good idea. But I do think that even for the edge, state management is solvable. It's still in the early days, but you're probably, as you can probably guess, that's a huge theme of investment for us. And so
Yeah.
I've met a bunch of these kind of edge data providers to see if any of them could win. I think the tricky part is the fastest data store is going to be the one co-located with the compute.
Yeah.
And Cloudflare has the best co-location story right now because their
Yeah.
databases can be co-located with the compute.
Well, it seems like there's a huge developer side to this because developers are more familiar with a basic CRUD application that has compute and a database, and there's a very simple model for how you get data from the database and how you update it. And all of a sudden, when you're in this edge data world, then you have to think about, okay, how do I reconcile the data across the cluster, across the world, and what are the approaches to do that? How do I deal with conflicts? How do I, and so then you're in a much more complex space than the typical CRUD or ACID transaction world, and the programming models today for this are pretty complex. We did an episode on CRDTs around this. We've done a few other episodes around distributed systems, and it's like, oh my god, like the where we're at in the programming model around this, there just seems to be no way that millions of developers are going to be able to grok CRDTs. And so we need these like higher level abstractions that make it so that you get something as simple as CRUD, but does the right thing in a distributed world.
This feels like something like structure concurrency, and then the way Rust does things, where it's like, okay, we're going to narrow your choices here, but in exchange, your thing will work right.
Yeah. Yeah. So what have you seen in the space of like developer programming models around this?
I mean, you said it, James, which is we've been looking for the abstractions in this space. We're looking for companies that take the most complicated ideas and make them more simple. I think we spoke about our investment in Temporal, but
Yeah.
this was a way to make durable execution a lot easier for developers. And I've looked at the CRDT space as well, and I agree that developers don't want to deal with CRDTs. And so, as the next level, I've now looked at developer tools that have a higher abstraction where developers don't necessarily see the CRDTs under the hood, but they still get some sort of framework that gives them just enough flexibility for their application and that programming paradigm. But it's still, I mean, there's some early projects in the space. One I like is called Vulkan VLCN. Matt Wanlaw has added CRDTs to SQLite, and he is trying to slowly build this vision out, but it's still very early days for this multi-writer problem.
Yeah.
And kind of merging conflicts.
Yeah.
Remind me what CRDT stands for.
Conflict free. You
give
it to us, Renee.
Okay. Oh, sorry. Conflict-free replicated data types.
Yep.
Shouldn't that be CF?
Maybe that's wrong.
Conflict. Yeah, I don't.
Unless it's conflictless.
I don't
replicated data types.
Conflict-free replicated data types.
So yeah,
so the F is just ignored. It doesn't fit into a nice acronym. So yeah. All right. So I think your analogy to concurrency is pretty similar in that most people can't get concurrency right. It's too hard. It's too complex to get right. And so structured concurrency gives this abstraction that doesn't work for every single use case of concurrency, but works for a lot. And so most developers, instead of using low-level concurrency primitives, should just use structured concurrency. Mm-hmm. And yeah, I think similar with what's happening in distributed data is maybe CRDTs are that thing that most people won't be able to get right. It's too complex, but then we'll see the higher level abstractions around it that work for most use cases. And hopefully at some point make it as simple as CRUD.
Mm-hmm.
Yeah, that's the hope. And we're definitely seeing that in some of these front-end frameworks, because a lot of people want frameworks to build multiplayer apps or local first apps, and they need some data syncing as well. And so this is almost the flip side of the edge, but I've thought about what framework would be needed to build Figma today. Like, there isn't an easy developer abstraction just for this idea of multiplayer. Or if I wanted to build Google Docs, how would I do that today without deeply understanding CRDT and OT technology?
Yeah. So run us a little bit deeper on this with the multi-writer problem, because you'd mentioned that kind of being the foundation of the challenges around distributed data. Give us a little more on what that is.
Yeah, I mean, at the highest level, it's the idea that if two people are writing at the exact same time, how do you determine which write is accepted in the database as the source of truth? The reason, and it's a very hard problem to solve. especially when you don't want a system that's just eventually consistent. But I think it is overstated in the industry in some ways simply because there are very few applications that absolutely need those guarantees. And so we also think about what class of applications would really need, a really sophisticated multi-writer system. For most applications, you can sort of get away with the status quo. So I think it's really for real-time gaming type applications on the edge where it might be very, very important.
Yeah. It again reminds me of concurrency, where you've got different strategies that you can use and they're each good at solving a particular problem, but there's not the universal one size fits all solution for distributed data dealing with the multi-writer problem. Just like in concurrency, there's not a one size fits all solution, and so that complexity at some point leaks through to how you solve your problem, and that creates obviously complexity and challenges for the developers that are building this stuff. And I think that's where is there a possibility to get something as simple as CRUD, or do we just have to admit that okay, there's different strategies, and based on what you're doing, you're going to have to pick one of these strategies?
Well, it feels like we're maybe, you know how there were the abstractions that wanted networking to be like, oh, it's just like
just ignore the
file.
network exists,
you ignore the network. And I feel like and it's the same when you look at the Rust lifetime system. When you start seeing it, you go, oh, wait, we've been ignoring this all along. And they said, no, let's use math thinking to, make this deterministic. And you're going, oh, I have to do more when I'm writing the code, but the benefits are, vast.
Yeah.
And so I'm wondering if this isn't a situation where it's like, oh yeah, there's this piece that we've been unconsciously ignoring.
Yeah.
Some aspect of networking, probably.
Embrace the things that you cannot change, which in this case, you cannot change the speed of light, unfortunately. If we could, that would surely solve these problems. We can't change the speed of light. So we have to embrace that the speed of light is what it is, and we have to work with it.
Well,
right.
And the other thing is that it's very uncertain whether your message gets through.
Oh, yeah. Yeah.
And how do you decide whether it does, whether to retry, all of those things? And I feel like there's something essential in there that we just haven't been able to see yet that could shift this. Yeah. Anyway.
So coming back to the compute side, it does seem like Wasm is emerging as the way to run workloads on the edge. I guess maybe early efforts were JavaScript and Node, and it's like I don't want to write JavaScript, and so Wasm gives us that edge capability for edge compute, but in a way that I don't have to use JavaScript. Is that how do you see that?
That's exactly right. So our excitement around WebAssembly directly ties to this edge shift. I think too many people use the words edge and serverless interchangeably. So I actually think it could relate to a serverless shift, and serverless can run on the cloud or edge. I'm not saying that's edge necessarily.
Right. Yeah.
I think, as you mentioned, James, one of the huge benefits is the polyglot developer experience. You can write in Rust, you can write in C++, it all compiles to Wasm. It doesn't lock you into JS the way kind of Cloudflare initially did. There are also other benefits, which is that they're very lightweight. That's great for the edge and constrained devices. Wasm modules have low startup times. Again, the cold start problem has always been an issue. People think Wasm can solve that. And then, the security properties are great. A lot of these primitives have great security properties.
Yeah.
So
there's a good built-in sandboxing around Wasm because it was created to run in the browser, so you have to have a good sandbox there. So
that's exactly right. Yeah, it's it has a very strong sandbox, and we do think that WebAssembly could be this edge IoT primitive, And I think the really interesting part about WebAssembly, again, if everything works and there's a lot of work in the community still being done, but you could run the same Wasm module on an autonomous vehicle. You could run it on the cloud. You could run it on the edge. You have
On your
that
phone,
portability story on a
in the
microphone
browser. Yeah.
browser. And so I know write once, run anywhere has almost become a trope,
Oh
but
no, it's totally a joke. Yes, the Java
yes,
version, they gave that up.
Yeah.
They don't say
right.
that anymore.
It's a meme at this point.
Mhm.
But and I'm not saying we'll ever get to a full write once, run anywhere world, but I think Wasm has certain properties that could make writing applications and deploying them to multiple platforms easier.
What have you seen in terms of technologies in the space for specifically for Wasm kind of Wasm servers? Yeah.
Yeah, I mean, there are a bunch of Wasm clouds that have popped up that I think are extremely compelling.
So you're
So
just like, give it your Wasm instead of giving it your Docker container, give it your Wasm file, and boom, you're up and running on the cloud.
yeah, a lot of them have done developer tools for WebAssembly. So they have frameworks to easily write a Wasm application. They help with the deployment and packaging. And then the way these companies monetize is they have their own clouds, but you don't have to run that application on their cloud. It's sort of like what Vercel is doing with Next.js. They're saying, okay, we were the Next.js people. Vercel is the best place to run a Next.js application, but it doesn't mean you can't run it somewhere else. And the new WebAssembly companies we've seen are sort of doing the same thing.
Yeah.
And they are getting huge cost savings, performance benefits. Certainly, we need to see if enterprises think that's enough. It's hard to get enterprises to switch, it's hard to get people to work in a new way. And the cost savings and performance benefits and ease of use all need to be 10x better. Typically, if a technology is 2 or 3x better, it's not enough to merit the switching costs.
Huh.
But
Yeah.
we're certainly hopeful that this is, again, really a paradigm shift in the way people work and not just some incremental improvement for developers.
Yeah. Yeah, and so I can imagine that these cloud providers would give you kind of just transparent global compute, right? You give it your Wasm and they're going to just run it on all these edge nodes all around the world. And then you still have to figure out the data problem. But at least on the compute side, you're automatically distributed and don't have to think about how you set up a CDN and how you then do global, what's it called? Global something routing, like where you go through the multi-point CDN and then it figures out which data center to route that to. And I mean, maybe you still need to there needs to be something there to do the routing, but I would guess that they're kind of building that infrastructure all for you, so you don't need to think about it.
Yeah, and you're bringing up some ideas that I think are really, really cool. I haven't seen anybody working on them because they're so next level, but where you can understand the server closest to the user, and you don't have to be locked into one of the cloud providers. Like you can get access to all the cloud and edge pops out there, and somehow it hits the closest server to the user. Like I think
Yeah.
that would be incredibly cool. And second, which
Some ideas
maybe
from BitTorrent need to
yeah,
come back,
exactly.
maybe. That was exactly what BitTorrent was kind of doing. Is this distributed mass shared? Yeah. Anyway, sorry.
And you said you also look for developer tools. Did I get that right? Yeah.
That's
What
right.
kinds of tools?
That's right. We sort of use developer tools and infrastructure interchangeably. Um, we mean anything where the developer would be either the user. They're generally not the buyer. Developers don't want to pay, but certainly they're the user, and we hope somebody in their organization would be the buyer. But then traditional developer tools, when I think of them, I'm more like, you know, in IDE or something to test code or even a CI/CD system. We look at all of that traditional stuff, build systems of observability tools. It's more fun to talk about the next level stuff versus talking about, oh, who's going to disrupt Datadog or Splunk or all these kind of enterprise tools. But we obviously look at those in great detail as well.
Yeah. Um, So I think that maybe some of this comes to functional programming. I know that you've done a bunch in the space of functional programming, and my belief is that functional programming not just helps with developer productivity, but could also, in a significant way, help with the shift to distributed systems, with the shift to how we think about refactoring from something that is calling something else in memory versus something that is then calling another thing over the network. And that refactoring today can be very hard because of the typical intertangledness of our state in our application. But functional programming seems to be a way to kind of help us get closer to that kind of refactorability to a distributed
The
system, I
way I
guess.
would put it is, as your systems get more complex, you need more reliability guarantees. And that's, I think, ultimately what functional programming gives you, is that reliability.
Yeah. The ability to say, this is a pure function and I know that it works. When I compose it with this other pure function, I know that it's still going to work and give deterministic behavior. And then, the effects and state kind of muddy that a bit, but maybe functional programming. I guess in our work with Zio, we've seen that Zio can definitely help with that as well. But
oh yeah, and you see, I mean, company like Microsoft has started incorporating Rust into its code base, into its operating system code base. And so that's definitely reliability oriented and functional oriented. So
Yeah.
what
Yeah.
do you see in this space, Renee?
Yeah, functional programming is the dream in a lot of ways. I think there have been two challenges historically. One is just not enough developers know functional programming, and that has been challenging for mass adoption of some of these frameworks. But two, and I think an area of investment for us and an area that could change this is, how do you use functional programming principles but mask that complexity to the average developer? So when a developer just goes to a boot camp, they're obviously, going to learn JavaScript or Python almost certainly.
Yeah.
How do you enable those developers? And analogies we've heard is that, and you guys can correct me on this if I'm wrong, but when React came out, people thought that this was some odd functional programming framework and it was so complicated. And then all of a sudden, people realized the ease of use and a lot of the complexity was actually appropriately masked. And so we've certainly looked for frameworks that use functional programming principles under the hood, but can still target the masses.
Yeah, I think there's definitely I guess there's two forces that I see around this. One is that more developers are being exposed to functional programming concepts, and that's helpful in moving things forward. And then the other one is that there is abstractions being built on top of the functional primitives that make functional programming more approachable. So in our work, we're writing a book with a friend here in Crested Butte called Effect-Oriented Programming, and we're using a Scala 3 and a framework called Zio, which is a monad-based functional programming library, and it's
for concurrency.
And it we've been working on this for a couple of years, and it's been a fun project. But
not a couple.
We've always struggled with, how do we expose developers who aren't familiar with functional programming constructs to these very kind of difficult, challenging ideas like monads. And Zio just recently came out with this abstraction where you don't have to use the monad model to program in Zio anymore. It's called Zio Direct. You just write your code just like you would normally without monads, and then underneath the covers it's still based on the monads and unraveling into that. But as we teach developers about Zio, we no longer have to start with, and here's what a monad is, and take like 10 chapters.
Is a huge blocker. Which is, I mean, I still feel like nobody explains it well.
Yeah.
And
burritos didn't work for you?
None of the things worked for me.
So for me, Zio Direct was one of the first places where I saw, okay, let's have the mathematical based the things that we can prove work and are lawful and are reliable, and then let's create the abstraction so that all of this is approachable to and familiar to most
Well, I think the
developers.
Rock language was trying to do that, and
Yeah,
I think Rust does that a lot. They never mention monads, but they're clearly, I can see them being used.
Yeah.
So, but in a different and more accessible way.
Yeah.
I think there are answers there
Yes.
in those languages. Anyway, what are your thoughts?
I mean, Zio Direct sounds very, very interesting. And I've followed the Zio project for a long time. You know, it's done great in the Scala community. And now we're seeing more functional programming principles being brought to TypeScript, which I think is very interesting as well. There's a project called FPTS. There's another one called Effect. And I think the two actually recently merged. But the idea there, I think, is very, very interesting because at its core, these are TypeScript frameworks, but they're bringing functional principles to TypeScript. And so you're kind of combining two things. TypeScript's very easily understood. They're bringing functional properties, but hopefully making them a bit easier to use. And I think frameworks like that certainly have the potential to go mainstream. And I'm looking for more of these almost hybrid frameworks.
Yeah, with the abstraction, like the right foundation with functional programming, but with the abstractions and the languages that make things more accessible to a broader developer community.
It's a big shift.
Yeah.
But I mean, and there are things like Arrow 2, which we're looking forward to in the Kotlin world.
Yep. Yeah.
And that's sort of like Zio for Kotlin.
Yeah, similar
so
ideas.
You might see some things like that. But I do find that the explaining the ideas, there is so much of the curse of knowledge going on there. There's so many assumptions people make when they start trying to explain these things.
Right. And
it's just they're complex subjects, right? Like,
yeah, but they could be explained a lot more straightforward.
That's what we need you for. You explained objects to me 20 whatever years ago. So, so now you're trying to do it with concurrency.
But Bruce, I also hear your point that maybe a more mainstream way is just the absolute proliferation of Rust that we've seen in the enterprise. I mean, we have seen so many traditional applications getting rewritten in Rust. And I'm not saying Rust is a functional language, but I do think that it's giving huge performance benefits, huge safety benefits. And it's just been uncanny. Like, I'm trying to think of examples. There was a framework called Electron, which is a way to build desktop apps.
Sure.
And now there's one called Tauri, which is
essentially. I just came across that. Yeah.
Oh, did you? Yeah.
I haven't played with it, but it looks really interesting.
It's really interesting. And this is an example of a project that's just been trending on GitHub. And I see it every single week gaining adoption. And from my understanding, I haven't played with it, but it's basically Electron written in Rust. And it's getting much better performance, and it's much more Electron is not well liked amongst developers, and people seem to really love Tauri for desktop apps. And we've kind of seen this pattern of a hated technology, and then it gets rewritten in Rust, and people seem to like it a lot better.
And in the Python community, there's a bunch of tools that are either being rewritten in Rust or being written from scratch in Rust. And it's funny I don't know, it makes a difference in so many ways. That speed and the amount of time that it takes for the brain to wander, and when you can cut that down, it makes a difference. And I don't know. I'm still.
So in Mojo, which you explored a little bit, was Python and Rust or something?
Well, it's a very crude approximation. They start with a Python interpreter and they embed something that takes a lot of the syntax from Rust, and it seems like it may, even grab some of the, implementations of Rust, and it's embedded inside of Python. And so instead of, the really good way to write Python extension modules is using this Rust library Pyo3. But this guy, who is the same one who came up with LLVM and Swift and something else, he said, oh, what if we, for the performance stuff, what if we just embedded all of the best stuff of Rust inside of Python? Then everything's backwards compatible with Python. And when you need the performance, you just write fn for a function instead of def, and you use structs instead of, Python's structures. And you get, that's a vast oversimplification. Yeah. It can also talk to the GPU. It can, do all kinds of things that Rust enables you to do. So anyway.
We've seen a huge overlap between the Rust and Python community and the Rust and JavaScript community. There's a Python linter called Rough that has been gaining a lot of traction. It's just a linter, but it's written in Rust and the performance is a lot better. I believe Pydantic is doing a bit of a Rust
Pydantic
rewrite.
2 is being written in Rust, yeah.
Right. And it's so interesting. There's a data frame library called Polars, which is a direct Pandas competitor.
Yes.
That the Python community uses, and it's Pandas written in Rust.
Rewritten in Rust. And so, and of course in data science, that's huge. And so,
it's huge.
And everybody's switching to Rough. And
what's Rough?
Rough is this linter, but the other thing it does,
that's a place where having performance and low memory usage is
because
essential.
you want to run it with
faster.
Hesitation.
If your linter can run in 1 millisecond, that would be perfect.
And this one is effectively, did it run? That's that fast. But it also incorporates all these other disparate linting systems that you would end up running, one at a time. Yeah. And now everybody's just switching to Rough.
Wow.
Yes.
I've been using it. Yeah. So.
Yeah. And I think what's interesting is that the best of these are not telling Python developers, hey, you have to go learn Rust. They are still creating thin Python layers, Polars, for example. You can still write in Python. It's just Rust performance under the hood. Mm-hmm. And I think getting that hybrid story is really, really interesting.
Oh, yeah.
And then it's the Python Rust story is well understood. And then we're starting to see that even in the JavaScript world a bit, where some of the JavaScript tooling now, I believe there's a project called SWC. I always get the acronym wrong. Turbo Repo, which is Vercel's CI/CD system, they publicly wrote that they were rewriting in Rust. It was historically JavaScript based. Mm-hmm. Some of these JavaScript runtimes we're seeing now being rewritten in Rust. So it's just Rust is touching almost every language community, whether the devs themselves realize it or not.
Yeah. And for those that it's not touching, hopefully Wasm and the Wasm component model will let us take other languages and integrate them with Rust Wasms, and that will be another kind of integration path across languages.
Well, because, one of the things that I'm interested in Rust in the Python community is often your performance is some weird little bottleneck in your Python code, and you can just rewrite that part in Rust. And then maybe you're not going to wander into the concurrency minefield and all that. That to me, that's like step one, profile, see if you can rewrite it in Rust, see if that solves your problem, then stop. Don't go to concurrency if you don't have to.
And use AI. So AI just says, hey, I did a performance analysis. Here's your hotspot in this function. I'm going to rewrite it to Rust for you.
Mm-hmm.
Boom.
Sure.
Done. There's a startup.
You might need a little coaching to get the Rust code to work right, but
yeah. But to your point, the component model and that polyglot story of we could have different Wasm modules written in different languages. They all compile to Wasm, then they all kind of link and integrate together. That vision, I think, is so interesting.
Oh, yeah.
And then the ability to transparently take one piece of Wasm compute and instead of running it in the same process, move it out across the network to another process. Mm-hmm. And boom, now we've got a transparent distributed system model.
Some serious concurrency there. I know we're reaching the end of our allotted time, but I'm also very curious if you can summarize, how did you end up in this job? What did you study in school, and how did you wander into becoming this, whatever it is that you do?
No, it's very niche. Honestly, I was at Google before this. I was in a product strategy role on a computer vision product called Shoppable Images. So it wasn't a neat fit to then going to be a developer tool investor. But I met one of my colleagues now, Mike Dauber, who was investing in this space, and he believed in me, and we had a bunch of great conversations. And now that I've been doing this for this long, I couldn't imagine doing anything else. But I would say there's no traditional background to become a developer tools investor.
Well, this was the moment when Bruce's computer blue screen of death. So sorry about that we didn't end properly, but hope you enjoyed this one.